All right, so super excited to invite up our next guest, Fran Bell. Fran runs a data science platforms team at Uber. She's got over 100 data scientists working on building tools that are a platform that's at a higher level of abstraction than Uber's already famous Michelangelo platform. Fran, welcome to TWIMLcon. Come on up. So I kind of paraphrased your role a little bit. Why don't you tell us a little bit about your team and your charter?
Yeah, absolutely. Thank you so much for having me. It's really a pleasure to be here at the inaugural TWIMLcon. About the charter of the team, the vision really is to provide cutting-edge data science at the push of a button to anyone within the company. So that basically means that we're aiming to transform anyone within Uber into a data scientist. An example of this is forecasting. So forecasting obviously underpins a large number of use cases within Uber. And so the vision here is to provide the latest and greatest cutting-edge forecasts to folks at a push of a button via UI, for example, as integrated into a BI stack, or programmatically accessible through our API. And so the only thing that our end users within Uber need to provide is historic data, whether it's, for example, in the form of a CSV file or a query, and the forecast horizon, so how far you want to forecast out. And we do everything else automatically in the background. We scan over a whole suite of forecasting algorithms, either those that we have integrated off the shelf into the platform, or also those that we have developed in-house proprietary. And we've gone way beyond forecasting in terms of data science areas. Other areas that we're investing heavily in platformization are anomaly detection, experimentation, more recently also conversational AI and natural language. And then personally, I'm very excited about our proof of concepts of also platformizing and semi-automating intelligent insights generation and data exploration.
So of those, conversational AI seems like the odd man out, so to speak. How did you end up working on that one?
Yeah, so we see a lot of really great benefits. We have a lot of conversational AI data at Uber. One example is our customer obsession ticket assistant, which was one of our first use cases in this space. So here, for example, we wanted to aid customer service representatives in solving customer support tickets that are coming in. And as you can imagine, given the size of our platform, we get quite a few of those. And so using natural language and deep learning approaches, we were able to build recommendations for our customer service representatives of what is the topic that folks are writing in about, what are potential actions that the customer service representative might want to take, and then also providing guidelines or guardrails basically around what could be the best starting point to actually address the response to the end consumer. Of course, the customer service representative always has the final call and say on this, but we saw really great improvements in our customer care experience as a result of having this AI basically assisting our customer service representatives.
Okay, cool. So you've got these this portfolio of platforms essentially that you're building to support these different use cases. How do you know when it's time to platform something?
Yeah, that's a really great question. And we're looking at multiple different dimensions here and very deliberately see which of the data science areas we want to platformize. It's obviously a heavy investment. And so we look at three items. The first one is, can the platformization of this area really create step function improvements to our user experience and the business? And so sticking with the example of forecasting, if we can forecast highly accurately demand in a particular space and time, we can create more magical user experiences. The second thing is really the wealth of use cases that exist across the company. Of course, building a platform, you want to be able to tackle many different use cases. And so with forecasting, for example, it does span the entire enterprise, ranging from marketing to obviously marketplace, supply and demand, financial aspects, operations, as well as our hardware. We still have a lot of hardware on premise, and so accurately forecasting the hardware needs, especially on high demand days and special days such as Halloween or New Year's Eve, is really important. So that's the second aspect. And then thirdly,
Halloween is a special day at Uber?
Yes, yes it is, yes.
Wouldn't have guessed that.
See lots of demand on that front. And then the third dimension really is the reusability of the modules and methodologies that we apply. And again, with forecasting, a common framework that is needed to build forecasting algorithms is a backtesting framework. So understanding the accuracy of your forecasts, and that really is needed for any step along the forecasting journey. And so having a common central parallelized language extensible backtesting framework is something that's really important.
Okay, so is your team out evangelizing the opportunity to platformize and looking for customers that are already working on things that meet these criteria, or are folks coming to you saying, hey, we've got these problems, help us solve them? How does the relationship with your ultimate customer evolve?
Yeah, absolutely. So we have a lot of the product teams coming to us with use cases. At the same time, because we are this horizontal team that spans across the entire company, across all lines of business, we have a very unique vantage point as well. And so we can also gently nudge some of the product teams to come and join us in this journey as well.
Okay, and so when you identify a problem space that it makes sense to platformize, how do you approach that? Do you just jump in and start building, start coding, or what does the methodology look like?
Yeah, that's a great question. So the way we build platforms is in a use case driven manner. So that basically means that with every use case that is strategically chosen, we augment the platform and we reuse as much capabilities as possible from the platform. And that really allows us to have wins very early on. And learning from this, we actually now have a three-phased approach to platformization. So step one is really consulting. So we have these deep domain experts in particular areas of data science on the team. And so we embed them with particular areas of the business where we see opportunities of having use cases in these areas. And so that has a couple of advantages. Firstly, the domain experts learn more about the business, about the opportunities, the pain points, and really can bring back these learnings to then drive the best design for these platforms. It also allows us to tackle these use cases early on and really show wins and gain the trust of our partners and leadership on that front. That, of course, is not a scalable approach. This is why we set out to do platforms in the first place, but it's a very good starting point. And so the second thing that we usually do is templatization. So what I mean by this is we build recipes, whether it's form of documentation, example IPython notebooks, providing talks and educational aspects. And this really allows us now to have a one-to-many multiplicative effect throughout the organization. Mostly to other data scientists that are dedicated to these business areas. And then over time, as we're taking on more and more of these use cases, we really expand our platform to become more and more self-service and work towards that vision of really providing it at the push of a button without domain expertise required. Of course, encoding best practices and guardrails in the process.
So in introducing you, I mentioned Michelangelo, Uber's low-level machine learning infrastructure platform. Uber was one of the first companies to publish about what they were doing to automate machine learning. If I interpret your LinkedIn profile correctly, you were at Uber doing applied machine learning platforms before, at least before that article hit, possibly before the Michelangelo effort even started.
Yeah.
What's the relationship between these two teams?
Yeah, we have a fantastic working relationship with Michelangelo as well as the AI organization engineering branch that we also work with very closely to platformize. And we have three modes of interaction here. The first one is, as the head of platform data science, I get pulled into the strategic and vision setting when it comes to Michelangelo, working closely with their engineering and product lead. So right from the start, there's a really great collaborative relationship that we can build on. And then we have two other modes that have evolved over time. The first one, as Michelangelo was more nascent, we deeply embedded folks from our teams into the Michelangelo group. So for example, with the Customer Obsession Ticket Assistant example that I mentioned earlier, this was actually the first deep learning algorithm that ran on Michelangelo. And so as you can imagine, a lot of the features required for doing deep learning were in a very nascent state at the time. And so having data scientists who are working on this particular problem deeply embedded in the Michelangelo group and working together with the engineers and product managers there to build our capabilities, not only to solve the Customer Obsession Ticket Assistant case, but also more generic aspects that then really benefited the community more at large to build deep learning algorithms and frameworks was really important here. Of course, as Michelangelo has evolved over time and became more mature, we are becoming more of an end consumer of the platform, and it becomes more of a self-service component, especially with the onset of TWiML. TWiML has really provided step function improvements to...
What's TWiML?
So TWiML basically allows us to write Python code and bring our own models that then basically via Michelangelo get deployed in a sandbox environment at scale. And so that really reduces the barrier to entry for data scientists to be less reliant on the native approaches that are already integrated in Michelangelo or software engineers that would help with productionization, for example. And so this approach has become really prominent across Uber and has really opened up new avenues for self-service on Michelangelo.
Okay. And so with your team pre-existing some of that effort, you've got platforms and use cases that you've stood up before they were mature and ready. Now that they're more mature and ready, is it a dynamic relationship in the sense that there's have you migrated any of those legacy models over to Michelangelo, or if it's there and it's working, you're going to leave it alone?
Mm-hmm. Yeah, that's a really great question. So we have a couple of aspects here. One is platforms that are more recent. So for example, a conversational AI platform, here from the get-go, we built on top of the Michelangelo capabilities and are actively utilizing this. Mm-hmm. But as you correctly pointed out, some of the platforms were built well before Michelangelo existed or was very nascent. And so we have our own independent stacks on this front. But here it's really important to see the opportunities for integration. And to see a timeline where some of these platforms are already or may be merging in the future. And then the third part is platforms that are currently standalone but likely will never merge with Michelangelo. So for example, our experimentation platform, which has very different types of methodologies and workflows, I wouldn't imagine would be combined with Michelangelo.
Can you elaborate on that? What about the methodologies and workflows makes them not good fits?
Yeah, absolutely. So here we use more statistical approaches, so hypothesis testing, multi-arm bandits, et cetera,
okay.
Versus the traditional machine learning approaches. And so for that reason, we keep them separate.
Got it. And so what are some of the key technical challenges that you face for this portfolio of use cases?
Yeah, that's a great question. So each of the platforms is different. We have different users, different use cases, and so therefore also different requirements on the technology side. Mm-hmm. But I can go into two concrete examples here. The first one is for real-time anomaly detection. This was actually the first platform that I've built at Uber. And so here the idea is that we wanted to detect system outages as quickly as possible. So people not being able to sign in or sign up, or perhaps trips being degraded, et cetera. And here we basically saw that this was still an open research problem. And we set out to build a new platform around it and also advance the space. We have a couple of patents now in that space as well. But here the key kind of requirement beyond the innovation component was that we needed to have extremely low latencies. So as you can imagine, because it's a real-time problem, we had basically those considerations to take care of and extremely high QPS. Because we have hundreds of millions of signals, basically, backend as well as aggregate mobile signals that we're tracking in order to understand whether there's a system outage going on. Another one example is forecasting. As I mentioned earlier, we integrated our forecasting algorithms also into our BI stack for easy access through UIs. And so there's now a really great path where you can query a metric, you can visualize this metric using Dash Builder, an internal tool that we've built. And then you have this little button that says, I want to forecast this metric. And so obviously we want to make sure that we have a good user experience here and that people don't have to wait, minutes or hours.
Recurring theme here.
Exactly, right? And so having low latency for some of these forecasting algorithms is really important.
And so are some of these technical challenges ever a reason why you might build something from the ground up yourself, so to speak, as opposed to rely on what the Michelangelo team offers? Or is that not a consideration typically?
Yes, it does flow into kind of our decision-making process here in terms of what is already available, how easily it is extensible, and often a timing kind of component comes in, as we discussed earlier, in terms of, where was Michelangelo when we started to build, and how can we evolve that in the future.
Can you talk a little bit about the technology stack that your platforms tend to rely on? Do you have your own kind of, not Michelangelo, but you've got these higher level platforms that are very application or use case focused. Do you have your own kind of intermediate level of abstraction, or are you building kind of use cases more independently?
So when we don't build on top of Michelangelo, which is quite a few of our platforms, we build microservice architectures. We build them in Go and Java, actually, for performance reasons. Databases are typically in MySQL. Then we run our instances typically on-prem for efficiency reasons. And then several of our use cases are batch and offline, especially on the training side. But for those that we discussed earlier, where latency is something that we want to focus on, we use caching for optimization.
And do you rely heavily on open source in this area or publish open source in this area?
Yeah, both. So we're definitely building on the shoulder of giants and using open source wherever possible. I think Uber wouldn't have evolved as quickly if it wasn't for open source. And so utilizing the methodologies that have been developed by the communities is very essential. But we also are heavily invested in open sourcing ourselves as well. And we have quite a few open source projects. If we look at the data science domain, there are quite a few examples here as well. We have Pyro that was developed by the AI organization, which is a probabilistic programming language. We have Horovod that is a distributed deep learning framework on TensorFlow that has gained a lot of popularity in the community. There is Ludwig that was also built by the AI organization, which allows for a deep learning framework where you actually don't have to write code anymore to deploy and train models. And then more recently, our org has worked together with the AI organization to develop Plato. This is a very flexible and use case rich platform that allows for conversational AI, especially in the research and prototyping phase. And then also our causal ML package is a Python package that we recently launched in collaboration with our marketing team that basically covers uplift modeling use cases as well as causal inference in combination with machine learning. So yeah, quite a lot of efforts in that direction, and we're considering to do more.
And with so much out and available in open source that you're incorporating into these systems that you're building, reminds me a little bit of a podcast that we published not too long ago A quote that the guest mentioned that became the title of the podcast was machine learning or AI is a systems engineering problem. I wonder how much of what you're doing is systems engineering, connecting pieces that, you know, in many cases exist already versus kind of pure innovation and building new stuff.
Yeah, it's definitely a combination of both, especially because we want to be fast to market with a lot of these things. So we leverage whatever is already there. But more often than not, actually, we need to not only deploy the cutting edge, but actually be and define the cutting edge as well. And as I was hinting a little bit earlier, one example is the real-time anomaly detection platform that I built when I joined Uber about 5 years ago. And so here it became very quickly clear that with the scale that we're operating at, the real-time nature, the signal-to-noise ratio, because we actually would be sending PagerDuty alerts that would wake people up potentially in the middle of the night if our algorithm thought there was a system outage going on. And so we were able to break new ground very quickly in this space. And one other thing that really helped develop these algorithms to the precision recall that we needed was I put myself on call. I was very customer obsessed at
Wearing
this point.
the pager?
Sorry?
Wearing the pager?
Yes, wearing the pager for 6 teams, multiple consecutive weeks. I can tell you I did not sleep much. I was woken up a lot during this time. But that also helped to improve the algorithms really quickly. And to
Makes you want to get it right.
Yes, exactly.
Nice. So how do you, your team is kind of building very use case specific things, you know, very close to the end user, doing low level kind of infrastructure as well to support all of this. How do you organize, how do you build an organization to support all of this?
Yeah. So we are organized by data science expertise. So we have a forecasting team, anomaly detection team, experimentation team, conv team, computer vision team, et cetera, basically. And then, as many other companies, we are cross-functionally organized. So we have data scientists, and engineers, product managers designing, working together, basically building all of these platforms. When we zoom into the data scientists, we tend to hire full stack data scientists for these roles, exactly for the reason that you described. We see a lot of advantages to having folks who can write production level code, in addition to having this deep domain expertise in a particular data science area. And some of the advantages we see here already start in the design phase. So having somebody who has deep understanding about the constraints of the infrastructure stack as we're developing a lot of these things at scale with latency constraints can be highly advantageous, because things that might look good on paper might actually not work in the real world once we deploy it in these ecosystems.
Do you have examples of that? Things that look good on paper that didn't actually work out?
Yeah, so coming back again to the real-time anomaly detection framework. So at the beginning, we were developing algorithms that would have extremely fine granular data points. So we obviously want to have near real-time signal. And so we wanted to have an understanding minute by minute, or even in finer granularity, what was going on. And so originally we designed an algorithm that would require, multiple weeks of data to train. One way of how we did this is to frame it as a forecasting problem, and then have that minute granularity. And that obviously would be an extremely large overhead onto our database systems on that front. And so we basically designed the algorithm in such a way that we have lower, coarser granularity in more historic kind of aspects, and then very fine granularities overlaid as a secondary step in order to still capture the variance on, for example, a minute-by-minute level. So just having that kind of constraint in mind made sure that we didn't require unnecessarily high kind of overheads on our databases and unnecessary infrastructure cost as a result. So that's one example on that front. Another example of where we see a lot of advantages for having full stack data scientists is in the productionization step. Here we're trying to avoid handoffs in terms of a data scientist writing a script or a white paper and then providing it to a software engineer. We see a lot of opportunities for errors on that front, logical errors in particular. And so having data scientists to also write the production level code without such a handoff step is really important to us. And then finally, also developer velocity. As we all know, there is this prototyping step involved, and we're trying to exceed some threshold criterion that we've set out in the beginning of the design phase. And it's of course not known when are we going to exceed basically this threshold criterion. And so that can lead then to lag times. Once you have actually found an algorithm you want to productionize, that software engineer might be busy with other things during that time. And so again, having data scientists who can write production level code can really also help speed up that innovation cycle as well.
You mentioned developer velocity, and that makes me think of kind of velocity in the sense of Agile methodologies. Do you mean it that concretely? And is there a methodology that you've kind of evolved to or developed that works well in the context of these types of problems?
Mm-hmm. So the way we work is very closely in software engineering kind of principles, both in terms of best practices, in terms of our working structure. We work on a daily basis hand in hand with software engineers, so we have developed a lot of this. But I think you bring up a really good point in terms of developer velocity and productivity. And so a big goal of the platform teams more holistically is to really speed up that innovation cycle, whilst increasing accuracy of the various different methodologies employed, right? And so the way we see it is we have these 4 major steps within the development cycle of a machine learning or, broadly speaking, data science problem. You have exploratory data analytics, then this iterative prototyping phase, productionization, and then rollout and monitoring, and that closes the loop for kind of a new cycle to start off if there is a V2 that we want to progress in. And so building abstraction layers, higher level abstraction layers, and this is where a lot of the work that my team and collaborators are coming in to play really helps to facilitate not only for us ourselves kind of this cycle, but really for the entirety of the company to really go faster and faster around that loop.
So you're primarily doing this by hiring full stack data scientists. They're not easy to find.
Yep.
And we throw that term around like it defines concretely a specific set of skills, but not every full stack data scientist is going to have the same strengths.
Yep.
How do you kind of grow your data scientists, or if you find folks that need support in one or more areas, or how do you manage the kind of learning cycle for your team?
Yeah, absolutely. So when we hire for these roles, we also hire complementary, of course, right? So there would be some folks on the team who lean more towards the research side, and others who lean more towards the engineering and software development side, and folks that sit in between. So that's one aspect. And then there's a very strong learning and teaching culture at Uber, really continuously striving to improve oneself. And so we have a lot of programs, even within Uber, educational programs, everything from introductory courses to machine learning, all the way to domain experts, basically, who then give workshops and training sessions, hands-on, basically, courses. I've invested a lot in mentorship programs at Uber as well, building out a community across all of data science and analytics. Where we then partner folks, and sometimes we also do 20% projects, similar to what Google, for example, does, where we have people then immersed into various different teams to get hands-on experience, basically, in some of these domains. So yeah, I think continuous learning and teaching is something that's really, really important.
Okay. And what are you excited for going forward? What's the future of data science platforms at Uber look like?
Yeah, absolutely. So I see both at Uber as well as in the industry a big push towards these higher and higher level abstractions for platforms to really kind of commoditize it, to make it available to a broader audience beyond data science, machine learning engineers, and engineers, more broadly speaking. And so coming back to that four-step data science workflow or machine learning workflow that I described earlier, one of the gaps that we saw is that we didn't have any semi-automation or automation around data exploration or insights generation as a whole. And that's something that actually goes well beyond data science or machine learning workflows, right?
That's the first step of the four-step cycle?
Exactly, the first step, right? Where there is still a lot of human hours that need to go into that, to dig into the data, to understand and explore the data, and also for business analysts, right? A lot of the questions that they would be getting is, I have an important business KPI, and it moved up or down, right? Investigate, all the various different slices and dices of the data on what might have happened, right? And so what we have been starting to work on is a proof of concept to actually have an algorithm automatically scan through our data and to surface potentially interesting insights to folks, whether it's machine learning experts or business analysts, for example. And they obviously would go and dig into some of these suggestions and understand them more deeply. But here we see a really large opportunity, not only to save people a lot of time, but also to really open up new insights that might not have been discovered previously. And this is some of the feedback that we're getting from our early adopters in this field, that the machine was able to come up with interesting suggestions that they say wouldn't have come up themselves. And so I think that really will, if successful, will revolutionize how we do data analytics at Uber, and I think more broadly in the industry.
Awesome, awesome. Well, Fran, thanks so much for joining us here at TWIMLcon.
Thanks for having me.
Great speaking with you.
Thank you.